Hello all, I hope you all are able to maintain your focus on your studies, and exams from home is very much exciting for you. So here we are ready to learn the subject ubiquitous computing. We started with unit number 6, which is ubiquitous communication and management, and today in this session we are going to talk about service oriented architecture. Before we proceed further, I would like to read a quote written by Mark Weiser, the inventor of term ubiquitous computing. He says, long term, the PC and workstation will be there because computing access will be everywhere, in the walls, in the wrists, and in scrap computers lying about waiting to be grabbed as needed. So here, Mark Weiser's vision is becoming true. We are seeing the world embedded with small computer devices into everyday objects to augment them with new functionality and to build an environment which is full of distributed computers. So you can see around and look at the objects and have the feeling of computing everywhere. Now it is very much necessary that these devices which are computing need to talk to each other. We have already seen many scenarios which give us the importance of what is the role of communication in ubiquitous computing. So we will start with service oriented architectures. This will be our flow: service orientation at the network edge. Then we are going to talk about content based networks, programmable networks, overlay networks, cooperative networks, and mesh networks. So to start with, we'll talk about a shift which is taking place from network oriented to service oriented architecture. So traditionally, different application services were coupled to specific networks only because different applications were in need of support from the data transmission functions at different levels. So they were expecting, some were expecting sequencing, performance and reliability, channel sharing, data control and security, latency, these kinds of services. Now in this case, it was simpler to design networks to support one specific set of application requirements instead of having support for multiple applications that have different messaging requirements, because then they may conflict. However, this is posing a disadvantage that more complex multi-service networks need to be provided and maintained, and then it can become harder to integrate the data from applications that exist on different networks. So earlier the scenario was of network oriented, where services were considered belonging to a specific network only. So network had some services, and then those services in turn were subscribed by different users. But now the shift is taking place towards service oriented architectures, where users are playing important role. They are deciding on the services, and in turn those services are provided by a set of heterogeneous networks. So this is the shift which we are talking about. So for this we can consider example of, say, earlier it was like, for audio video contents I have to subscribe to audio video wireless broadcast networks only, or for calling facility we have to subscribe to only telecoms networks. So this was the earlier scenario, but now it is not true. So if we talk about service orientation at the network edge, then for simplicity purpose the networks have been divided into two parts. The one is access network or edge network, and the other one is core networks. So access network, as the name says, it is the network that users and applications are using to access the network. And core networks is including the interlinked networks that then link to access networks, so that for user it becomes easier to access the network part. Now here the design issue is whether we are going to keep the intelligence part with core networks or towards access networks, or we are going to divide it and we are going to keep it at both places. So if we consider example of core network, then that is PSTN. For access networks we can consider the example as IP networks. So there is an argument which says for end-to-end or edge-based complexity and keeping the core networks relatively simple, so that we can optimize the core network only to forward and route the data packets. So functions which we are going to place at lower levels may be redundant, or they may have a very little value which we compare with the cost of providing them that at that low level, then it is not justifying. So it is implied that we should have a network which is simple and as neutral as possible, so that intelligence, complexity and functionality is supported in the edge network by the applications. So we are going to talk about content-based networks, that is the infrastructure provided by these are some of the infrastructure provided which we are going to talk, and then for our purpose whichever is suitable that can be used. So content-based network is a network in which the flow of messages through the network is driven by the content of the messages. So here focus is on the contents rather than by linking specific senders to specific receivers. So we have this scenario where if we are interested in some topic, then we will go and search on the YouTube. So we will not see at who is providing those contents. Okay, we are just interested in the matter of that content. So this is the example we can consider to understand content-based networks better. So with this communication pattern, receivers are subscribing to the types of content that are of interest to them without regarding to any specific source. So I am not interested in knowing who is giving me the contents. I am just interested in the contents itself. So senders here are simply publishing information without addressing it to any specific destination. On sender side also, they are not interested in knowing who is using the contents. They are just publicizing it, and once it is publicly published, people are going to subscribe to those services. So this network is complementing traditional unicast and multicast network, which is providing improved support for communication modes underlying large scale, loosely coupled, multi-party distributed applications such as auctioning, personalized news distribution, service discovery and multiplayer games. So in these types of scenario, content-based networks can help. The next is programmable networks. So typically service providers do not have access to the router in order to optimize network use for different applications. So we know that router are going to control the environment, control algorithms, and router states are also controlled by them. So then user is not going to have the access to it. That is why deployment of new network services, which could be far more flexible than proprietary control system, is becoming impossible due to the closed nature of network nodes. So programmable networks are allowing some of the network elements to be reprogrammed dynamically. This is happening with the help of injecting executable codes that could support application specific services into network element such as routers and switches. Now the problem with this is that complexity increases and there is an increasing risk of instability and for malicious code to take control of core network elements. Even though this is a problem, but still this approach is beneficial one. So there are two main initiatives which are taken to establish programmable networks. So first one is DARPA's Active Networks program, and second is Open Signaling Community, OpenSig community. Now the difference between these two is that OpenSig approach is seeking to establish open programmable network interfaces where we can provide programmable contents which are available, whereas Active Networks approach is to support injecting executable code into network elements so that they are reprogrammed. So these are the two approach. Now there are several benefits with programmable networks. So the first one is it has ability for applications to maintain information about device capabilities. It has ability for networks to respond to application status and resource requirements also. It is said that with programmable networks, better allocation of bandwidth and resources can be done. It is giving us high performance at the low cost, and because we can add the new services without changing much of the things, so monetizing these new services can become faster, and above all, for user it creates a fantastic experience. The next is overlay networks. As the name says, overlay network is a virtual network which is built on top of a physical network that provides a virtual infrastructure to one or more applications. So underlying network is there, and on top of that this overlay network is built. It handles the forwarding and handling of application data in a ways that can differ from or in competition with basic underlying physical networks such as internet or PSTN. So it is not mandatory to have ways which are similar to core network, underlying core network. It may have it similar to it, or it may differ with that way. It can be operated in an organized and coherent way by third parties also, and this may include collection of end users. So application specific overlay networks can be incrementally deployed on end hosts running an overlay protocol. For example, based upon a distributed hash table with modified routing without requiring changes to the physical routers. So we are not making any change to physical router, but still with the help of distributed hash table the routing can be modified. The next type of network is cooperative networks. So here, before we discuss it, we are going to consider three scenarios. So the first is, some networks may have access devices where multiple networks are not there. So there is a single network, so there we can just have access to one network connection. Now this is often in order to simplify the design, or we may reduce cost with the help of it, or because redundancy is not necessary. In that case this scenario will work. The second scenario is, we can have access to heterogeneous networks with inbuilt support. So for example, Bluetooth, infrared, Wi-Fi and GSM networks can be there, which are providing heterogeneous network access. Now each of these networks must be used in isolation. So it is not the case that I can use Bluetooth as well as infrared. They are not going to interoperate. And the third case is that multiple types of the same type of physical and network layer may exist because multiple independent users and providers may offer overlapping wireless networks within the same vicinity. But yet again these do not interoperate. So even though there are many services available in the same vicinity, but still they are not going to interoperate. So cooperative communication is designed to enable single antenna mobile access devices to get some of the benefits of being multiple input multiple output systems, that is MIMO systems. We already know about MIMO systems. So cooperative communication treats communication nodes as if they are part of WMN, but multicast the same message over multiple routes with different fading effects to the same receiver. So receiver is going to receive number of messages with the same contents, but it may have different fading effects. So it is up to user, receiver, that he is going to decide how which of the content it is going to choose, and WMN here stands for wireless mesh networks. So here power consumption can be reduced for transmission even when it ought to increase as multiple users are now using each transmitter. So this is the benefit of cooperative networks. A specific problem that cooperative communication can solve, which we have already talked about, is at the physical media layer they are going to concern the signal fading part. Now because of thermal noise, shadowing due to fixed obstacles and due to signal attenuation, it can vary significantly over the course of a given transmission. So this can be handled with the help of cooperative networks. Transmitting independent copies of the signal that will face independent fading generates diversity and can effectively combat the deleterious effects of fading through combining these multiple signals. So basically, cooperative networks are going to help the user Next in the line, we are going to talk about mesh networks. So we already know mesh network is a network where each node in the network is connected to every other node. So in full mesh topology, as you can see, every network node is connected using point-to-point connection to every other one. So the problem with this is connecting every node to every other node is costly to wire and also costly power wise to transmit it to each other. So hence in practice, mesh networks are usually partial mesh networks, as you can see, in which each node is actually not connected to every other node. Partial mesh networks tend to combine ring and star based network topologies together. So then we are going to talk about wireless mesh networks, that is WMNs. So these are partial mesh ad hoc networks that can significantly improve the performance at a lower cost and at a lower power output compared to other types of wireless LAN connection. So WMN is a low power because it is going to use a set of lower power multi-hop transmissions instead of having single more powerful transmission to a base station. Now this may be suitable solution in rural areas where conventional base station wireless type network support or DSL support may not be available. However, each WMN receiver is now more complex and more costly as it must also act as relay, as we have already seen. So as you can see in the diagram, so there are a set of clients who are going to get the contents through these mesh routers, and there is a gateway which is going to connect it to outer network. So there is only one device which is going to be actually connected to the gateway, and all are then going to receive the network connection through that single device. So instead of using a sophisticated and costly centralized base stations, each wireless receiver in a WMN can act as a relay point or node for other receivers within the range. So WMN acts as kind of cooperative networks for its users. We have already talked about cooperative networks. So WMNs can be used to supplement a commercial Wi-Fi network to attain greater range and higher capacity. In colleges, in universities, in cities, in offices also, these kinds of wireless mesh networks can be installed. In wireless mesh networks, each node is operating not only as a host, but it is also acting as a router, which is called as mesh client, which is going to forward packets on behalf of other nodes that are actually not within the range, direct wireless transmission range of their destination. Now in addition to this, dedicated mesh routers are also going to be there, which contain additional routing capabilities and bridging and gateway function to other networks. So WMN can also dynamically self-configure, self-organize and self-heal mesh connectivity to support ad hoc multi-hop networking. So it is very easy to add nodes in the wireless mesh networks like plug and play. It can configure it, organize it, and even in case of failures, it is going to self-heal itself. These are the assignment questions which you are going to add to assignment number 6. And I hope you have understood different types of networks which we have seen, like programmable networks, cooperative networks, content-based networks, mesh networks, and also we have understood how the shift has taken place from network oriented to service oriented network models. Thank you. Catch you later in the next session.